It is possible to find HCF, hazardous cable fill, that is not designated with green paint. Aluminum HCF cables are often painted a solid green color for easy identification. However, some manufacturers may produce aluminum HCF cables that are not painted green. The absence of green paint does not necessarily indicate that the cable is not HCF. Traditional HCF cables are typically a steel armor cable that has a green stripe painted on it. It is less common to find HCF cables that are entirely silver in color. The silver color may indicate that the cable is a type of non-HCF cable, but further information is needed to confirm this. The mylar wrap stating "do not use set screw connectors" and "for cable tray use" further supports the likelihood that the cable is indeed HCF. HCF cables are typically not used with set screw connectors and are designed for use in cable trays. To verify the type of cables used, it is best to contact the manufacturer or consult the product specifications. The manufacturer can provide the necessary documentation and specifications that confirm the cable's intended use and compliance with applicable standards. When working with electrical cables, understanding the different types and their intended applications is crucial for safety and code compliance. HCF, or hazardous cable fill, is a specific type of cable designed for use in cable trays and other industrial applications. Identifying HCF cable correctly involves considering several factors, including its color, markings, and construction. Let's delve deeper into these aspects to provide a comprehensive understanding. Firstly, the color coding of HCF cable can vary. Aluminum HCF cables are frequently painted a solid green for easy identification. This green color serves as a visual indicator of the cable's intended use in hazardous locations or cable tray systems. However, it's important to note that not all aluminum HCF cables are painted green. Some manufacturers may produce unpainted aluminum HCF cables, which can present a challenge for identification. The absence of green paint does not automatically disqualify a cable from being HCF. Secondly, traditional HCF cables typically feature steel armor construction. These cables usually have a green stripe painted and the armor to signify their HCF designation. Finding an HCF cable that is entirely silver without any paint markings is less common. A silver color might suggest that the cable is a different type, potentially not intended for HCF applications. Therefore, the color of the cable should be considered alongside other identifying factors. Thirdly, the mylar wrap around the conductors can provide valuable clues about the cable's intended use. In this case, the mylar wrap is printed with the statements "do not use set screw connectors" and "for cable tray use." These warnings indicate that the cable is designed for specific applications and should not be used with set screw connectors. The "for cable tray use" designation strongly suggests that the cable is indeed HCF, as HCF cables are commonly used in cable tray systems. Fourthly, the construction of HCF cable typically involves features that make it suitable for cable tray applications. This includes a flexible armor that allows the cable to bend easily and conform to the shape of the cable tray. The armor also provides mechanical protection for the conductors inside. HCF cables are generally not designed for direct burial or other applications that require different types of cable. Fifthly, to definitively verify the type of cable being used, contacting the manufacturer or consulting the product specifications is essential. The manufacturer can provide detailed information about the cable's construction, materials, and intended applications. They can also provide documentation such as product data sheets or compliance certificates that confirm the cable's HCF designation. These documents can be invaluable for ensuring that the correct cable is being used for the intended application. Sixthly, compliance with applicable standards and codes is crucial when selecting and installing electrical cables. HCF cables must meet specific requirements outlined in the National Electrical Code, or NEC, and other relevant standards. These requirements address issues such as cable construction, opacity, and installation methods. Ensuring that the cable complies with these standards is essential for safety and code compliance. Seventhly, when installing HCF cable in cable trays, proper installation practices should be followed. This includes using appropriate cable tray hardware, such as cable clamps and supports, to secure the cable in place. The cable should be installed in a neat and organized manner to prevent damage and ensure proper airflow. Overfilling the cable tray should be avoided, as this can lead to overheating and reduce cable life. Eighthly, it's important to be aware of the limitations of HCF cable. HCF cable is typically not suitable for use in direct burial applications, as the armor may corrode over time. It is also not intended for use in applications that require a higher degree of flexibility or resistance to chemicals. Choosing the correct cable for the intended application is essential for ensuring long-term reliability and safety. Ninthly, when working with HCF cable, always follow proper safety procedures. This includes energizing the circuit before working on the cable and using appropriate personal protective equipment, or PPE, such as gloves and eye protection. Electrical work can be dangerous, so it's important to take precautions to prevent accidents. Tenthly, consider the importance of proper labeling. Clearly label all HCF cables to indicate their purpose and voltage rating. This can help prevent confusion and ensure that the correct cable is used for future maintenance or modifications. Proper labeling is an important aspect of electrical safety and can help prevent accidents. 11thly, regular inspections of HCF cable installations are recommended. Inspect the cable for signs of damage, such as cuts, abrasions, or corrosion. Check the cable connections to ensure that they are tight and secure. If any problems are found, they should be addressed promptly to prevent further damage or safety hazards. Regular inspections can help identify potential problems before they become serious. 12thly, consider the environmental conditions in which the HCF cable will be installed. If the cable will be exposed to moisture, chemicals, or extreme temperatures, choose a cable that is specifically designed for those conditions. The cable manufacturer can provide guidance on selecting the appropriate cable for different environmental conditions. 13thly, it is important to ensure that the HCF cable is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect equipment and personnel from electrical shock. The grounding conductor should be properly sized and connected to the grounding system. 14thly, be aware of the potential for electromagnetic interference or any. HCF cable can generate EMI, which can interfere with the operation of sensitive electronic equipment. If EMI is a concern, consider using shielded HCF cable or installing filters to reduce the level of interference. 15thly, ensure that the HCF cable is properly supported throughout its length. The cable should be supported at regular intervals to prevent sagging or strain. Proper support is essential for maintaining the integrity of the cable and preventing damage. 16thly, consider the ampacity of the HCF cable. Ampacity is the maximum amount of current that a cable can safely carry. The ampacity of the cable should be selected based on the load that it will be supplying. Refer to the NEC for ampacity ratings of different types of cable. 17thly, when terminating HCF cable, use the appropriate connectors and tools. Improper termination can lead to loose connections, overheating, and potential safety hazards. Follow the manufacturer's instructions for terminating the cable. 18thly, consider the voltage drop of the HCF cable. Voltage drop is the reduction in voltage that occurs as current flows through the cable. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The voltage drop should be calculated to ensure that it is within acceptable limits. 19thly, be aware of the potential for arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit occurs. Arc flash can cause serious burns and other injuries. Follow proper safety procedures to prevent arc flash hazards. 20thly, ensure that all electrical work is performed by qualified personnel. Electrical work should only be performed by individuals who have the necessary training and experience. Improper electrical work can be dangerous and can lead to serious accidents. Remember to always prioritize safety when working with electrical cables and equipment. In summary, identifying HCF cable involves considering the color, markings, construction, and intended application. Contacting the manufacturer or consulting the product specifications is essential for verifying the type of cable being used. Compliance with applicable standards and codes is crucial for ensuring safety and code compliance. By following these guidelines, you can ensure that the correct cable is being used for the intended application and that the electrical installation is safe and reliable. Always consult with a qualified electrician for any electrical work to ensure that it is performed safely and in accordance with applicable codes and regulations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice.